work this one out for you. Make sure you know how to do it. Okay, it says the enthalpy change of converting 1 mole of ice at negative 50 degrees Celsius to water at 70 degrees Celsius is blank. Okay, the specific heat of ice, water, and steam are 2.09 joules, grams Kelvin, 4.8, blah, blah, blah. Anyway, they are all the constants. So basically, we need to calculate the enthalpy it takes, the energy it takes, really, to convert ice, so water, from ice to liquid water. Okay, so if this is a water enthalpy problem, then you're going to be setting up the diagram like this. Kind of look like this, and I'll show you a slide of it so you can see it better. Okay, and this is going to be, let's see, temperature. No, temperature's over here. Okay, so here we're looking at degrees, so this is going to be, this temperature is at 0 degrees, and this one is at 100 degrees. So at this point, we're looking at steam, okay, because we're looking at water, and 0, that's when we're looking at freezing. Okay, so here's the freezing point of water, here's at 0 degrees, and here's at 100 degrees. Okay, and what we're going to be doing, okay, we're starting, I don't know, I'm making up a point, but right here, we'll say that's at negative 50 degrees, and we want to go up to about right here at 70 degrees. So each time we hit a plateau, that's a calculation, and anytime we have a diagonal, that's a calculation. So we have 1, 2, 3 calculations to do there. Okay, so here is area 1, number 1. This plateau is at area 2, and this diagonal here is area 3. Okay, so there's 3 different calculations. Now let me show you the slide here. Here's a good example of all the formulas and everything you could use. So here, do you see this green area is 1, then we have purple, and then we have red, then we have blue, and we have red. So we're going right here at about negative 50, okay? And it says the formula to use for this area, for area A, is Q, or heat, equals mc delta T. Okay, again, because you look here, here is the temperature, we lined it up, and it's about right in here. And in that area, that green area, this is the formula it says to use. Okay, so for area 1, so number 1, the formula is mc delta T, and it gives us our, you see our C right here, that's number 1, is 2.09 joules per Kelvin, or per Celsius. Okay, now let's look at area 2, which is this plateau right here. So we match this up. That's B right here, this purple area. If we follow that, it says the formula to use here is heat equals N delta H. So here it equals to N delta H. Delta H at this point, you see right here I gave to you as 6.02 kilojoules per mole. And right there, that equals 2 moles. And then now let's look at area number 3, which is the next area. So just follows order, 1, 2, 3, 4, 5. So the next area we need to go up to is right, about in here, about 70 degrees. And it says that formula for that whole entire area there is mc delta T. So just like number 1. mc delta T, but the difference here is that C now equals to 4.18 joules, grams, degrees Celsius. Now, why are the C's different? This is the heat capacity, because we're looking at a different phase change. Okay, so let me come back. If we're looking at the temperature, okay, think of water. Water freezes at 0 degrees Celsius. So this right here is at 0 degrees. Anything below that, it's ice. Okay, right? So it's a solid. So this is a heat capacity 2.09 for solid ice. Okay? Now up here, heat capacity, so we're above 100, or above 0, I mean, so from 0 to 100, any temperature between there, that's when it's liquid water. Okay, so now we're looking at a liquid, so the heat capacity, the C, is now 4.18 because we're looking at a different phase. You know, we're looking at a solid versus a liquid, and so the energy associated with that is different. So they have different C's. And you notice here, if we went all the way up to steam, think about steam, water boils at 100 degrees Celsius, okay? So anything above 100 would be steam. So the heat capacity is 2.01, okay? So again, it's a little different because we're dealing with steam. Now right here, at 0 and 100, you notice those are flat points because here we're looking at as an actual phase change. Okay, in between here, these are all the temperature ranges where it's, you know, is a liquid. Okay, and right here at this point it changes, it starts to change into a steam, and anything above that it's fully steam. So wherever it starts to change, the temperature where the change occurs, no, it's the flat point, and here we have different delta H's. So the delta H for steam to convert water into steam is 6.02. Okay, but the delta H, you know, to go from freezing to liquid, so this phase change here is, where's, no wait, this one's 6.02, sorry, and this one over here is 40.7. Okay, so the energies are different, again, because different energy changes. So when you start these problems, you always look at where am I starting at, in this case, negative 50, so about right in here, so in that green area, and I'm going out to 70. So anytime you have a color change on this graph, I can make it bigger so you can see it. See here, green, purple, red, blue, red, but different color red. So I'm going from here, so the green area is A, that's one calculation. Then I have another calculation here, B, and then another calculation here, C, and I can stop there. Okay, but let's say I was trying to go up to 120 degrees, well then you would also include this area here, with be another calculation, and this area here. So let's do this problem here. We only have 3 areas because we're only going up to 70. Okay, it gave us that the moles of water equals to 1 mole. Okay, so if you convert this into grams, 1 mole of H2O, if you do the molecular weight of water, 1 mole equals to 18 grams. Okay, so you have 18 grams of water. Okay, so let's plug these in. For area number 1, we have MC delta T. M equals to mass in grams. Okay, so that's why I calculated grams right here. So we're going to have 18 grams multiplied by C, which we have is 2.09. And our change in T, so for this area, we're going from negative 50 up to 0. So we're starting at, so remember this is always final minus initial, okay? So our final, what we're trying to get to right here is 0 degrees, and our final temperature, our initial temperature was, so minus initial, and our initial was negative 50. Okay, so our temperature change there is 50 degrees. Okay, so again, anytime you're looking at one area, you know, like from here to here, you have to stop at each one. So we're not looking at the full temperature change, we're looking at the temperature change just in that one area, which would be negative 50 to 0. So we're not looking at again, that delta T is not negative 50 all the way up to 70. We're just looking at the temperature change in this one area, which would be negative 50 to 0. Okay, so here we have 50. If you plug this in, you should get 1,881. All right. Now let's do this one over here. So we have N delta H. We know N is, right here is 1 mole. So we're going to have 1 times delta H, which is 6.02 kilojoules. So when you multiply this out, you're going to get 6.02. Let me put the units here. So this is kilojoules. Notice this has a joule, so this is in joules. Okay, now let's do the bottom one here. MC delta T. My mass is still 18. I haven't changed it. My C I wrote down is 4.18. Again, notice it's in joules. And my delta T, so let's look at area 3 starts right here and goes up to here. So it starts at 0, so my initial is equals to 0, and my final, I'm going all the way up to 70, so that temperature change there is 70. Okay, if I multiply those all out, 18 times 4.18 times 70, I'm going to get 5,266.8. And that'll be in joules. Now let me show you why this is joules. Because, okay, your mass is in grams. Your C here is in joules divided by grams degrees Celsius. And your delta T is in Celsius. So your Celsius cancels right there, your grams cancels right there, leaving you with just a joule. And that applies for number 1 and number 3. Now look what we have here. We have this in joules with this in kilojoules. So our final answer is, it wants us to be in kilojoules, so let's convert everything to kilojoules. This one's good. Okay, so all we need to do is to divide by 1,000. Okay, so right here we'd have 1.881, and right here divide by 1,000, we'd have 5.2668. Now if you add all of these together, change my color again, I would have, let's say 1.881 plus 6.02 plus 5.2668. When you add all those together, I'm running out of room, let me put the answer right here, you get 13.16 kilojoules, which is your answer. So I hope that helps. So again, it's just knowing anytime you want to have the enthalpy of water, so the energy associated, and what you're looking at is the phase change, going from maybe a liquid to a solid, or it gives you different temperature changes. Or you need to look at this slide right here, look what areas it includes, and just do the calculations for those areas and add them all up together.